Hey everyone, one of the questions that I get a lot revolves around section 3.2, which is talking about truth tables in logical statements. Now before I show a couple of examples in here, I want to just make sure that we're all on the same page with the notation that we are going to use. A lot of times people will talk about truth tables and they will take a statement and they will refer to it as a letter like P and Q. P might represent the condition of a statement and Q might reflect like the conclusion, like hypothesis, conclusion. An example is it is raining and I carry an umbrella, right? So when I start to see this, and that is umbrella, that's a B. When I start to see this in a statement, when I put it together, I might say things like P and Q, right? This is and, meaning it is raining and I'm carrying an umbrella. If I do it this way, it is raining or I am carrying an umbrella. And probably when we start getting into logical statements like conclusion, hypothesis, conclusion, we imply. We say it now, if it is raining, then I am carrying an umbrella, right? So the idea in a truth table is to decide the truth of these statements. Is this a true or a false statement? The only other one that I think we need right now is this symbol, which is a negation. In other words, it simply means not. So if I were to say this, it is not raining, or I am not carrying an umbrella. Now, when we are working with this, it's important for us to understand that a statement like and means that both things have to happen, right? If I say it is raining and I carry an umbrella, all right, if somebody were to look outside and they see, oh, it's raining and Josh is carrying an umbrella, that's a true statement. An or statement means one or the other. So someone could look outside and say it is raining or he's carrying an umbrella, one or the other. All right, so let's take a look at what a truth table then is starting to imply. So when we look at a truth table, what we're using is this idea of an organizational strategy in order to just say this is true. Now here we're using the letters W and Z, and it's asking this question, W or not Z, okay? Imagine this was raining an umbrella. This is saying it is raining and I am not carrying an umbrella, okay? In order for us to understand that, we start with something simple. If this is the statement, I am carrying an umbrella, Z, we have in a truth table just said, well, Z could be true or false, right? The reason we have it listed many times is because you'll start to see the combinations of events. Like this is, both of them are true, W is true and Z is false, W is false and Z is true, both of them are false. As you add more conditions like W, X, Y, Z, you have to have more layers of the table because you have to say, well, what if all of them are true? What if all of them are false? And all of the combinations in between. So just focusing on Z, the opposite of Z is really easy, or the negation of Z is really easy to figure out because if Z is true, the negation of that is false. If Z is false, the negation is true. True and false, right? I'm just saying the opposite. So I looked at column Z and said, here's the opposite, all right? Now we get into actually putting two things together. Now I'm looking at both of them. I'm looking at W or the negation of Z, right? So again, the key, since it's the V shape, it's or. If one of those things is true, the whole statement is true. So for example, let's assume this is, it's raining and I'm not carrying an umbrella. If I look at just those two statements, it is raining outside, I am not carrying an umbrella. Well, that W is true means this or this is true. When I move down one, both of them are true. W and not Z are both true, so it's obviously true. In this one, however, neither of them. W is false, not Z is false. So this is a false statement. And here I've got one of them is true. False, true, that's got to be a true statement. So when you're thinking or, one or the other has to be true. As we continue to build on that, you'll see here I've got a more complicated looking one. If we break it down and look step by step, it becomes a little bit easier because I am just, first of all, looking at, here are three things. My name is Josh, your name is Jim, his name is John, right? Or person one is Josh, I mean, those are just names. It's your name either is Josh or it's not. It's true or false. The reason, again, that we have so many lines in this is because here all three of them are true. Here the first two are true. The first and third are true. Here only the first one's true. You know, and they basically have broken it down so that we have all the combinations of true, 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 false, true, false, true, false, true, true. It's like all the combinations down to all of them are false, right? So let's evaluate these statements by themselves. Here is the opposite of B, or the negation of B. Well, if B is true, then this one has to be false. True means false, false means true. It's just the opposite of whatever B was originally. Now, a lot of people don't need to do this step because they can think through a lot of logical things together. I use it all the time, right? I'm basically breaking this down into small chunks so that I can just focus on two columns at a time and not have to try and think about all three of them. Now, the next part of this statement is in parentheses, so you'll see they did it next. A and not B. The and is important because that means they both have to be true in order for this to be a true statement. If they're not both true, then it's a false statement, right? So, I am going to look at the A column and the not B column. True, false, they're not both true. True, false, they're not both true. True, true, they're both true. True, true, they're both true. False, false, they're both false. False, 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 true, false, true. There's only two times where A and the negation of B were true. So I put those in here, right? And again, now you'll see the reason why we break this up into steps is because now I'm going to look at this column, the A and not B, and I have it broken down. I have it all false and true, and column C, or column C. Again, the A and not B is together as one. So this column, or C. Now again, the or means one or the other has to be true. All right, if one of them's true, the whole thing's true. So when I'm looking at this, true, false, I have a true. So that one has to be true. Both of them are false in the second one. Both of them are true in the third one. One of them's true in the fourth one. One of them's true in the fifth one. Neither of them are true in the sixth one. One of them's true in the seventh, and neither of them are true in the eighth. And so as I go through, again, and means they both have to be true, or means one of them, right? So when you're going through these things, you really are trying to break this down into steps, okay, and do them logically. Now we have one additional one that's a little bit more confusing for people, but the first parts of this I think are again straightforward. They've filled out this table with everything that we did before. Here's A and B. Notice B and not B are just opposites. A or not B is filled out right here. Then they did A implies B, right? That one's a little bit trickier, and I just want to explain that. If you were to think about this statement, if it's raining outside, then I'm carrying an umbrella. The only way to prove that statement false is to find a day where it is raining outside and I am not carrying an umbrella, right? If you look outside one day and you look and see like, oh, it's not raining outside, that means the condition is false, so you can't base anything on it. The only way you can prove something false is basically catch them in that lie. it's raining outside and you're not carrying an umbrella, that's a false statement. Everything else is true. So that's why this one looks kind of weird. The hypothesis is true, and the condition or the conclusion is true. That whole statement is true. Hypothesis true and conclusion false. It is raining, but you're not carrying an umbrella. That's a false statement. These two, when the hypothesis is false, it doesn't matter. Like, well, it's not raining, so I can't judge it, so I'm going to assume it's a true statement. That's these parts. And that's the hard part to get for people to wrap their head around. They see that statement of, if it is raining, then I am carrying an umbrella, and they look outside and they see me carrying an umbrella on a day when it's not raining, and they're like, aha, you lied. I didn't say I only carry an umbrella if it's raining. In fact, I may just carry an umbrella all the time, but I guarantee I'll have one when it's raining. So that people get lost on that a little bit, and we'll come back to it. But once all of these things are done, the parentheses are showing you the two columns to look at. We want to look at the column with A or not B. That's right here. Or the column with A implies B, which is right there. So I just need to compare these two columns, and the or statement is all I really care about. If either one of these is true, the whole thing is true. One of them is true in the first one. One of them is true in the second one. One of them is true in the third one. One of them is true in the fourth one, right? So I go through and have all of these ideas about whether or not this is a true statement. And then furthermore, something that I think is a little bit trivial, a tautology is a statement that is true in every single set of circumstances. This is a tautology. All right, so let me go through and do a couple other ones. Use variables to rewrite the given compound statement. If I am at the store, then I will buy milk. So I'm going to make M, I am at the store, N, I will buy milk. The idea of using an if-then relationship is that arrow. So if I'm at the store, I'm going to use the keypad for this, implies that I will buy milk. Whoops, I need the N, not the N. So that's what this looks like. If I'm at the store, then I buy milk. If I were to change that and say I am at the store and I buy milk, it would look like this. I am at the store, I will buy milk. If I am making a statement that says I am at the store and I am not buying milk, it's just translating that. So since I've defined them as M and N, here is, if I'm at the store, then I will buy milk. And the same thing for something that's a little bit more complicated. It is cold outside, it is summer, Hannah goes to the beach. Those are the three things. It is cold outside, it is summer, Hannah will go to the beach. Now I have to start thinking about this logically and say, well, if it is not cold outside or it is summer, that's the first part, one of those things. So if it is not cold outside or is summer, so not cold outside is the opposite of A. So let me just start filling this in. The opposite of A, or it is summer, or is the upside down one, and summer is B. So this part says it is not cold outside or it is summer. I am going to, because I'm using those two things together, I'm going to put parentheses around these. And I should have done the parentheses first, so I'm just going to recopy what I have here. Not A or B. And I have it in parentheses because I'm going to use that and say, based on that question, then Hannah will go to the beach. So again, whenever you see that line or arrow, it means if all of this stuff, then this happens. Hypothesis, conclusion. This says if it is not cold outside or it is summer, then Hannah will go to the beach. Hopefully that helps wrap your head a little bit around truth tables when you break them down. If you need more or additional examples on that, please don't hesitate to let me know.